My name is Mark Galpin. I work on as the product manager for Conant. I work for JFrog. How many of you have heard of Conant before? So this is way many more hands than I get most places, so this talk might be a little bit basic for some of you. But if it does feel like it's too basic, I have some more advanced discussions that we can get into that I'll be happy to do. Just as a note, I know that when I get excited, and Conant is a very exciting topic, that sometimes I start to speak too quickly in a foreign language. So if I do start doing that, hopefully I won't, but if I do start doing that, please somebody just feel free to call me on it, and I will slow down again. It's just, you know, some things are really exciting, and you want to get through everything. As I said, I work for JFrog. The Conant team in general is interested in hiring. Not that many positions in Russia, though, so this is really not a terribly useful slide, probably, but not necessarily completely out of it. So for today's agenda, just a couple of simple things that I wanted to go over. I want to build C, C++ faster. Why should we do package management at all, and why with Conant? What does CI/CD look like with Conant? And then I'm going to do a demo and a Q&A. Hopefully my demo actually works. I expected to have a few more minutes to double check it, and had a little bit of an adventure getting here. So, but I think it should be fine. So let's start with the problem statement. We all love being C, C++ developers. Well, OK, so fine. I have to confess, I'm not really a developer anymore. But once upon a time, I was. And when I was, I coded in C. As Diego likes to say, I never coded in C++. I used C with classes. The cool thing about being a C or C++ developer in the modern world is that there's a decent chance you're working on some of the coolest stuff that's happening in software development today. You know, people that I talk to in the C, C++ world are building automated cars. They're very heavily involved in pretty much anything related to IoT or embedded devices. The new wave of automation that is going through the world. The problem with being a C, C++ developer is that very often your tools, with the notable exception of your IDE, feel a little bit like this. For those of you who don't recognize this game, this is Frogger. It is one of the older color video games in the world. It's about as old as I am. And there's nothing really wrong with Frogger. It's a great game. It's been remade on pretty much every single platform to exist. You can get it for your phone right now if you want to play it. I've seen kids playing it in the airport. It's a perfectly good game, and it works perfectly well. But you know, when you're building the coolest, newest, most cutting-edge thing in the world, you would like to feel like you have cool, cutting-edge tools. And most C developers I talk to do not feel that way about their tool set. It's getting better. It's getting better, but you know, not quite there. And the real place where people feel this pain is when it comes to how long their build takes. How many of you have a build that takes more than an hour to run? Quite a few hands. If I ask this question at a conference made up primarily of Java developers, I get very few hands that are raised anymore that say that their build takes more than an hour to run. Back when I was a developer, my builds took about 4.5 hours. I know this because I was the person in charge of doing the weekly build, which meant that on Thursday night, I told everybody that they got to go home early, And I stayed, and if I was really lucky, I got to go home in 4 hours. And if the build didn't go well, I was lucky if I got home that day, as opposed to sometime on Friday morning. Those of you who've done build engineering have doubtless had this experience as well. And so anybody who does own a build has their own reasons to want it to go faster. But that's really not why we want builds to go faster. Sorry, build engineers out there in the audience, but while I do want to help you, if all I was doing was meaning that you could go home early once a week, that wouldn't really be the point. The problem is that if it takes 4 hours, you can't really do anything that we would call modern continuous integration. Right? If you're really lucky, you can do a nightly build. But you certainly can't build multiple times during a day. And so package management is really designed to solve this problem, right? The idea behind package management, and particularly package management with binaries, is you build it once and you use it many times. This makes the build itself much faster because it means that you're building less. And the less you build, the faster it goes. But it also reduces risk. There are many, many ways to screw up a compilation. I should know I've probably done most of them at some point in my life. And every time you recompile a binary, you run the risk that it will run differently than the last time you compiled it. Now, granted, if you wrote your code correctly and your tooling correctly, this should not happen. I, on the other hand, have had the dubious pleasure of being called from the test floor and having somebody tell me, your build doesn't work. And I said, so what do you mean it doesn't work? He says, well, we're testing it, and these 5 things that you swore worked and that worked in QA don't work here. What do we investigate? We investigated that we'd only ever QA'd the debug binaries. I ended up sending debug binaries to the test floor for an acceptance test. It was not a good day for me. The other thing that used to be a good approach to this, right, and certainly the approach we used to take when we wanted our build, is the things that almost never changed, right? When you have a multi-million line source repository, usually at any given time there's a huge chunk of it that almost never changes because you're not working on that part. Maybe it's the core bits, maybe it's some pieces out on the edge. Wherever it is, there's usually some large chunk of it. Unless you have a very, very large team, you're not working on multiple millions of lines of code at once. And so back 10, 15 years ago, an easy solution to this problem is we would just check our binaries into Subversion. And whenever somebody wanted to build, they would pull them out of Subversion. Now, don't get me wrong. From the very first time I started using source control, back when it was CVS, back some time ago, I was told by the person who introduced me to source control, and wasn't that a revelation in my life from leaving college and somebody saying, no, this is what you do, you check your source into source control. And the very next thing he said is, and check only source into source control, we don't check binaries into source control. And every time I was ever told what is source control or had any sort of talks, and I gave talks as I introduced source control at another company later, about source control, we always said, don't check binaries into source control. And yet, at every company I ever worked at, we did, in fact, check binaries into source control. And that worked fine until somebody created a source control system that actually followed some of the basic principles of source control. And then the binaries got really bad. And of course, the source control system I'm talking to you about is Git. And checking binaries into Git, in Subversion, it didn't really matter whether you checked in a binary or a text file. In Git, it starts to cause some very serious problems, especially even if it doesn't change very often as it starts to change. And then you've got more binaries, and you do a Git clone, and you're checking out the entire history. And I actually managed to brick one implementation of Git because it wanted to be able to, in order to do a Git clone, it wanted to be able to bring the entire Git clone into memory before it gave it to you. And I had checked in a 1 gigabyte binary by mistake. I was playing with Git LFS, and I checked in a 1 gigabyte binary by mistake. And it was a very small, low-memory machine that I was testing on. And it could no longer load the entire thing into memory, and it just died. Could not access that Git repository again. So these are the sorts of problems that package management solves. It allows you to manage binaries in a sane and sensible way without checking them into source control. It allows you to reuse them, etc. What's the problem? Well, first of all, C++ projects are often quite a bit larger than you find in most other languages, with the possible exception of Java. And the builds are likewise longer, as we've discussed. But additionally, there's this new extra little twist that makes package management a little bit more challenging. And that is, of course, you have transitive dependencies. You want to do binary management for all the reasons we've discussed. But what does C++ have that Java doesn't? It has ABI compatibility issues. And this is why you can't, for example, easily use Maven to manage your C++ packages. And I've seen people use Maven to do all sorts of weird and crazy things in this world. But if you want Maven to model ABI, you're pretty much pretty stuck. And just to add to the fun, in C++, because we have to model ABI, it may be that your dependencies aren't the same on every platform. So this is the example of OpenSSL that sometimes requires zlib. And if it's in Windows, it requires special Windows libraries that aren't in the standard library package that it needs to know to depend on. And if you're building a lot of cross-platform stuff, you need to have a package management tool that knows how to solve these problems. And thus Conant. So Conant works cross-platform. It's used every day at hundreds of companies worldwide on Windows, Linux, Macs, even for Android builds. It's completely open source. I'm not an open source fanatic, but you really shouldn't be using something this low down in the infrastructure of your code that isn't open source. So we have Conant under the MIT license. That's about as open and free to use as it gets. If you would like, you are welcome to fork it and start selling it tomorrow. Please don't. But the license does allow that possibility. You don't want everything to depend on a central repository. If you're running an enterprise, you need to have control over what you built and where it came from. It needs to manage binaries to speed up the build, but it also needs to be able to build from source, because there are so many different ways that you could have to compile something, so many different platforms that any given C++ library should be addressed to. OpenSSL has 400 different configurations that we are currently tracking and aware of for its binary. You need to be able to build from source if you're working with C++. It needs to model ABI compatibility, and it needs to be powerful and easy to configure. So we give it a client-server model. Just out of curiosity, how many of you have heard of Artifactory? How many of you have heard of Baruch? Baruch Sadegorski? I'm just curious which number is higher. In a Java audience, Baruch is actually sometimes better known than the product he advocates for. So we have a server-client architecture, and the options are you have bin tray or Conant Center up in the cloud. We have a little server that we're using mostly for test purposes that comes with the client. And then there's Artifactory. A couple months ago, JFrog released a free version of Artifactory for C, C++ developers that you can use under any circumstances that works with Conant and with generic binaries, because obviously C++ developers have more than just Conant packages that they need to manage. Conant Center. So Conant Center is for open source C, C++ packages. The idea is that if you're depending on a popular open source package, rather than have to go out and figure out how to package it yourself, it should be available on open source. We have a community called Bin Crafters that has been packaging a lot of very popular C++ binaries. I know that there are some bin crafters in the St. Petersburg community, but I don't know them by face, so if you're in the audience, thank you. If it comes with pre-built binaries, many people don't want to use the pre-built binaries. They would rather, they would rather build it from source themselves and store it locally so that they know the full compile, but we want to give you pre-built binaries so that you can get started really quickly, especially if you're trying it out. And it has recipes that should build, if it's in Conant Center, it should build pretty much on any platform you can imagine. And there's about 500 packages available right now in the open source community as a whole, and about 105 of them, last time I checked, had gotten through all of the quality filters to get all the way to Conant Center. So it's still baby steps. If you want to get involved with Conant, there's a great community around packaging open source packages. It's a great way to get started, play with it, learn about it. As I said, we have Artifactory Community Edition for C, C++. It's free. It's usable anywhere. It is based on Java. Everybody has their sins. But being based on Java, that makes it really easy for it to run on anything. So it's pretty cool. And what actually happens now? So a Conant package has two pieces. It has a recipe, which basically gives you the information that you need in order to build the package and to consume the package. And it has what we call package binaries. Package binaries are pre-built binaries based on a specific ABI and configuration. On the client side, I have the same thing. I have the recipe and the binaries. It may be a locally cached copy of something on the web. It may be something I'm creating. I grab the recipe. If I'm running a client and I don't have anything locally, first I'm going to grab the recipe. Then, based on the environment I'm trying to build in, I'm going to go out and get the specific package binary I want. So in the example on this slide, I wanted Linux GCC 6 version of the binary. So it goes out and it asks the server, hey, do you have a built version of this binary for Linux GCC 6 debug? And the server says, yes, I do. Here's the binary package. Or it says, no, I don't. You're going to have to build that one from source. Go follow your build from source instructions. And we do this by effectively hashing the settings that model the ABI. And we have a specific set of options and settings that we model: release and debug, the architecture, the compiler, the OS. We also model what version of the standard library you're using, and things like that. So let's get to the demo. And let's hope that my demo actually works. So first of all, one of the things I'm demoing today is a couple of months ago we released the beta version of a plugin for CLion. I'm hoping that there are some CLion users in the audience here. Hopefully, some of you. We would like you guys to try it. We want to bring this into the official CLion repository. Right now it's on our own GitHub. It's not yet in the official CLion repository. We'd like to move it over to the official CLion repository. But we're struggling a bit to get an intersection. A lot of people in our open source community are not using CLion. And a lot of people in our enterprise community won't test something that's still in beta. Which leaves me in kind of an awkward position where, I wanted, a certain number of users to try it out and give me feedback that said it was good to go before I, marked it 1.0 and uploaded it to the official repository. And I'm having a little bit of trouble getting to that mark of users, just because kind of, like I said, there's sort of a bit of a mismatch between the people using CLion and the people that I have easy access to persuade to try new stuff. So if you want to try something a little bit cool and a little bit fun, please try out this plugin and then drop in on our Slack channel, file a GitHub issue saying, hey, I tried this out, it's great, or I tried this out, it sucks, whatever the case may be. We want your honest opinion. We're not trying to inflate anything. It's a pretty simple plugin. It allows me to match. Thank you. I love you too, PowerPoint. As I said, I love PowerPoint too. Okay, let's start this again. It's a pretty simple plugin. All I have to do is I have to tell it, how does my CMake profile match? Is this big enough that people can actually see it?
I guess you can make it a little bit bigger.
Let me see if I can, in fact, make it bigger. There has to be a way to make the menus bigger in CLion.
You can help find action presentation, but make it properly.
Enter presentation mode. Okay. It's bigger, yes, but not quite what I had in mind. Let's see here. Exit presentation mode. Let's see, that has to be view, exit presentation mode. Okay, let's try.
Just change the screen resolution.
Yeah, let's try that. Oops, that's not what I'm looking for. That one. Let's try that. Okay. This is, okay, now where'd my project go? There we go, perfect. This is a little bit weird what it's done to it, but I think this is going to work. Okay. Now you can see a little bit better than you could before, hopefully. This is probably about the best I can do, so we'll go with this. So all I'm doing here is I have to set my Conant profile and my debug profile, and you see I have a couple of Conant profiles that I pre-configured. And now that I've done that, I can run a Conant install. And you can see that it's going out and it's looking for Poco. Oh, right, sorry. So all I have here is a Conant file.txt. So this is just saying these are the dependencies of my system. And I'm saying here that I depend on Poco 178. I depend on Boost 1660.
You can go to settings and change the font to the size, to the stone.
Do you have a comment plus shortcut?
I don't remember. Like, may I do
Yes, go ahead. Sorry.
It was a good idea. Let me first do this. And
I do apologize. This is my first demo with live demo with CLion, and I did not consider this this aspect of it when I was testing it. Ah, perfect. Thank you.
like it's quite ugly, but it's
For our purposes, it'll be good enough. So all I have here is I say I depend on Poco, a specific version of Poco. I depend on a specific version of Boost. And in this particular case, I'm going to want to run all of this with CMake as my build system. It doesn't have to be CMake. It could be pretty much any build system I want. But CMake is an easy one. And you see it goes out and it gets Poco. In order to run Poco, it needs OpenSSL. So it goes and it gets OpenSSL. It gets Boost. Everything we want is available in Conant Center. And except for a version of Poco for debug purposes. I can find Boost, but I can't find Poco. And if I had to build Poco, this would take about 5 minutes, 10 minutes. But we're going to that's what the problem is. OK.
Would you mind explaining a little bit what you're doing there?
Yes. What I was doing there is I'm adding my own remote. And earlier in the day, I forgot the -i, so I'm doing an add -i0, which puts it at the top of the list instead of at the bottom of the list. The address here is from Artifactory. So if I were to go out to my Artifactory server, which I was going to show a little bit later, but we can show it here. And so it gives me the specific address through the setmeup command that I need, the URL of the specific repository that I'm pointed at. And in this case, that's localhost 8081 is, of course, the port I'm on. Artifactory is the specific extension on Tomcat. And then API Conant means that I'm using the Conant API to address it. And then Conant local is the repository. And I am calling this remote the terribly clever name localhost. And then I'm just deleting the package. And now we will do an install again. And did I update my Mac since the last time I compiled this? I bet I did. My version of Xcode has changed. How lovely. Well, I will show you how to build from source. When one part of the demo doesn't work, we'll show you the other part. So I'm going to do this from the command line because I have to admit that this can be done in CLion. I just don't know all the incantations to make it work quickly, and I know them from the command line much more easily. So install -- build missing. I'm actually going to say build missing, which means that it will build anything it can't find. And so it's downloading OpenSSL from Conant Center. It's downloading Boost from Conant Center. And now it will retrieve it from localhost because now the demo wants to work for me. I love you too, computer. This is the joys of live demos. But it is the point I was trying to make. I have timed this build. This took us probably about 30 seconds, give or take, including downloading things from the web. I have timed this build. If I had to rebuild Boost and Poco myself, this would be about 20 minutes. They're not fun libraries to build. So, and now, if I want, I can refresh that. And
You use debug profile in CLion, but default use default profile.
It used the default profile here. That explains why it worked this time and not the other time. Yes, because this one is you're right. I forgot to tell it to switch to the debug profile, which means it's using the release profile. And yes, I do have them all for the release profile. That would be the that's the difference. Yes. So as you can see, I can set the profile. So I can do this -- PR debug. And this time, it had to download Boost. And this will take quite some time, so we're now going to switch back to the slides while this runs. So that's the basics of Conant. I'll show you a little bit more about it at the end. We'll let this build kick off. So that's some of the basics of how to use Conant. I'm going to show you more of it at the end. But it brought up a question, is this a good idea? You know, we talked a little bit about why binary package management, but there are certainly people out there who would say, don't bother. You know, build everything from source every time. Now, most of those people have a lot more computing power than your average software build person has access to, but it's a good question. And when you get into binary management, you get into the question of versioning. And versioning is a tricky subject. I have an entire other talk on the subject of versioning, just for the record. And I'm working on a new one related to versioning of Conant. I'm not going to get into all of the details, but it begs the question, you know, if you're doing binary management at some level, you are implicitly versioning your builds in ways that, arguably speaking, when you're dealing with source, you don't necessarily have to. Right? At some point, if I'm dealing with source, I can just always build, you know, the tip of a branch and call myself done. If I'm dealing with binaries, typically it gets a little bit more complicated to know where that build came from. And that's what versioning does, right? Versioning provides a couple of basic critical features. It is for traceability and communication. I have a bug with what version of this code again? Where did this code come from? I have a bug. Is not helpful, right? I need to say I had a bug with version 1, and then support's going to say upgrade to version 2. It's also about automation and orchestration, right? It gets down to this basic question of, do I need to rebuild it? It's also about storage management. Do I care about that binary anymore? This is one of the areas that it's really easy to fall down on when you go to build anything managing binaries, is this question of how do I know when I can get rid of a binary? How do I know I can throw something away? And unless you have infinite disk space, this eventually becomes a question. I have a customer that's talking to me about, you know, wanting to do 2 petabytes of storage so they never have to answer this question. 2 petabytes of storage costs money, even as cheap as storage is today. It's a lot of money. Better to have a good cleanup policy, in my opinion. And I'm not quite sure why this title still says Docker. This was stolen from my Docker talk, but I thought I retitled all the slides. This is probably due to bad versioning of the binary that is my PowerPoint. So the point in automation is that you have a promotion process, right? That at some point, I say a binary has passed these set of tests, so now it can go on to the next stage of my automated or manual process. And again, I need some form of traceability for that. And you know, there's various things you could do, or you could just version it. Now, the problem with all of these things, with Conant as an interesting side note, is that with Conant you potentially have 2 different elements with different version numbers. And so I'm not actually going to say that Conant has solved all of the traceability problems in the world. It's something we're working on this year. this is kind of, that's the other talk, like I said, that I'm working on is kind of a quick talk on how to solve versioning in C++ for a much more complex solution set than just Semver can solve. And there are other solutions than Semver. There's Jenkins builds, there's Git hashes, there's a unique date that it was built on. They all have advantages and disadvantages we can talk about. But the key thing from our perspective is that when somebody is dead, you need to know who they are. When your software dies, you need to know why it died, and to know why it died, you typically need to know what software it actually was. Because otherwise, you just have this problem. Gets back to my anecdote from before. I had a perfectly good working library. It got to the test floor. It didn't work. And my first response, of course, was, it works fine on my machine. And so binary management exists so that, and this is kind of a generic workflow that we talk about for pretty much all languages, right? Because you start with code you're developing. You develop it locally. You use a tool like Conant to grab your dependencies. You can get them from someplace like Artifactory. You can get them from the web. And then you're going to check it into source control. And then the point of what's supposed to happen next is that somebody else builds it immediately to see if it still works. And this is where, if your build takes too long, this step gets to be really painful. And they use the same tools. And they go out there. And then the binary matures. You have a binary, it builds, it compiled, yay, it compiled. But sadly speaking, as much as we as developers sometimes don't like to admit it, it compiled is not at all the same thing as it worked. I wish it were, but, and we try hard in C to make it so that it compiles and it works are the same, but it is not always the same. And so now you have to test it. You may have to do some security analysis against it, depending on the type of application it is. You doubtless have to do some sort of functional test, probably an integration test if it's a more complicated application. Maybe even an end-user test, depending on exactly what all you're building. If you're lucky, you're not building a UI in C++. I've done it. It works. But it's still not always fun. And then you've got to deploy it somewhere, whether that's giving it out to people or putting it on a production server where it will actually work. But hopefully, right, you don't have a scenario where the developer builds it on his machine and pushes it to production. Right? You have steps in between. And hopefully, today, they are automated steps in between. For how many of you are they automated steps in between, just out of curiosity? How many of you have a lot of manual steps between these two things? Not too bad. Not too bad. And with something like Conant, this whole process gets faster. And we can do it with Jenkins. Now, there's been Jenkins builds of C++ for a long time. All Conant does is make it faster. Right? You retrieve the dependencies so you don't have to rebuild them. You build them with the tool of your choice. And then you upload it to Artifactory so that the next time somebody needs your library, they don't have to build it again. Now back to our demo. It's done. So now, We're going to upload everything. And you see that some of the stuff, as I went to upload it, it skipped it. It said, I already have this. I already have the recipe. I know that the checksum is the same. Don't send it to me again. This is one of the things that Conant works pretty hard on, is to make sure that you never have to send data that it already has. And this is something Artifactory also works pretty hard at. And now, I could, in theory, run this whole build again. I could wipe it all out. We could start the demo from the beginning, and I wouldn't have to rebuild it. But I'm going to do something different. I'm going to change my code. Very simply, I'm going to add a dependency. And I'm going to add a dependency over here.
You forgot the semicolon.
Oop. Thank you. I've been writing Groovy too much lately. And I go to build this, and it, of course, tells me that there is no version 0.1 of hello, because hello is not in Conant Center. Let's fix that. So here I have a simple Conant file. There's a couple of different ways I could have done this one. So if I wanted to, I can do Conant init. Hello slash 0.1 Mark G slash random. And it will create a template conantfile.python with a whole bunch of careful instructions on how to use it. So it fills in the name and the version number I gave it, and then it says, you need to find a license, you need to give it a URL, you need to give it a description.
I missed a bit. Where are you now doing this?
OK, so I'm building. I wanted to depend on a hello library. I haven't actually created the hello library, so now I'm working on creating the hello library.
So you're in the local corner?
Yes. So this is a local repo of my own. I'm off on a separate project now that owns the hello library. And so one of the things that the hello library could do, right, is they could create a Conant file from scratch. Now, before we had a Conant file.txt that just had a couple of requirements. This is a slightly more complicated file. It's a Conant file.py, which is a Python file. And this needs to be a Python file because now I'm not just providing, saying, I need these libraries in order to do my build. I'm also saying, this is how you build a package in Conant. And I can use the Conant new command, and it will give me a template. Since you have already witnessed the fact that I can forget a semicolon when I'm inserting one line of code, I am not going to try to write this template from scratch today. We're going to go back to our pre-built one. And I'm going to go through what you have here. So it's hello, it's 0.1. It tells me that the settings that matter for this library for binary compatibility are the OS, the compiler, the build type, and the architecture. That its only option that really matters is whether it's a static or dynamically linked library. And that by default, it will be statically linked. And it is only taught to run on CMake. Now, there's a couple of different ways I could have built this library. In one way I could have built it is I could have a hello.cpp and a hello.h right here in the directory. In this case, I'm acting more like I'm a build engineer or something. So somebody else has a hello library. I'm just trying to wrap Conant around that hello library. So I'm just going to go out and tell it to run a git clone to get its source, rather than rather than try to download the source or use something locally. Just go run a git clone and go to hello, and then check out the static shared version of the library. And other than that, this is pretty much boilerplate. My CMake is just going to build itself, and I want to package .h files and .libs, .dlls, or .as, depending on what platform I'm on. And the lib is going to be hello. So, so there we go. And off it goes. This is a much faster build than Boost or Poco. So I just had it went out and it git cloned things, figured it out, what I needed. And, oops, wait a minute, 1 second. I forgot. There we go. And I've created a hello package. Now I can upload that package. So now I've created the package. I want to upload it to my server. So I say, yes, I want to upload it. It uploaded the recipe. It would have helped if I'd put this command in at the beginning. -all means I actually want to upload the binaries as well. And it uploaded both the debug and release version of this binary. And now I can remove hello locally. So if I do a Conant search, there are no packages with hello left. Now we go back here. And
You should change test or test.
oh, thank you. Live demos that involve writing code. I try to avoid it whenever possible to avoid exactly these problems. By the way, I should mention this is actually technically a version range. I'm saying give me approximately 0.1 instead of exactly 0.1, so it can take a couple of versions that the system deems equivalent to 0.1. Come on. Why are you not taking the fix?
It's still written as test there. I mean, in the console.
Oh, no, this is right.
We need just to comment this.
Ah. Possibly. Yes. Sorry, my IntelliJ is set to save automatically whenever I lose focus.
These kind of plugins are also expected to do it automatically on actions like
Yeah.
apply everything.
Yeah, there might be a bug in the plugin. And we can see that this time it grabbed hello from my server, downloaded and installed it. And we should be able to run now. Oh, wait, I need back to CMake. And now I can build it. And it is built. And now I can run. And it says, hello, world. So this was a really trivial demo, obviously. I made more code errors than I should have in a 15-minute demo. I do apologize for that. All I can say is that I've been enjoying your wonderful city of St. Petersburg, and apparently vacation has cut my edge off. Does anybody have any questions?
How did you figure out what to put in these text files for the package, which describes the API stuff? Like, how did you figure out that's debug and that's that compiler and these
So
for the hello package?
it's a perfect question. So in this case, all it did is I built with the profile. So I do Conant profile show debug. And it has pre-stored information about my Mac OS X, right? It knows that it's architecture x86-64, it's debug, it's compiler Apple CLang, the libc++, not libc11. Yes?
You have libc++ as libc.x, but your hello example did not apply it because you didn't wrap you didn't have patch make lists with Conant basic setup.
Yeah, no, yes, you're right. I built the demo too quickly. And the compiler version, the rest of the settings it did get automatically. The getting the libcxx in, you actually, as he says, you actually have to tell CMake to do that.
On Mac, it's by coincidence it's work.
Yes.
It's
Yes. Yes, exactly. On a Mac, it will work by coincidence. If I was on a different machine, it's a little bit more risky whether it'll work or not. The one that used to kill me was all of our recipes used to be built for, everything we had was built for Apple CLang 8. And when I moved to 9, everything needed to be updated. And that was always a little bit fun going through and making sure that all of my profiles were updated. You can also store your profiles in Git, by the way. And we have a Conant profile get so that a developer doesn't have to know these settings offhand or create them themselves. They can just get the settings from a repository. Other questions? Yes?
I've heard about Conant multiple times, but I've never used it actually.
OK.
Let's let's say I have a laptop and a relatively powerful server,
Mhm.
and I want to set it up in a way that they run different operating systems, but I want to deploy my software written on the laptop on my server, or just build the software on the server and then send it back to me to the laptop. Can I do it with Conant, and which additional tools will I need? I mean, the minimum package.
Yeah, no, it's a fair question. So the answer to can you do it with Conant is yes. But this assumes that cross-compilers exist from your server to your laptop, right? So there are not, for example, to the best of my knowledge, any cross-compilers on Linux that will compile a macOS binary.
You may use Docker container as source of, as container of building container.
Yes.
You got C++ Rush, the presentation that the guy used Conant and Docker images.
Yes.
Together with both and use cross-compilation.
Absolutely. But you know, it does rely on the existence of a cross-compiler to get from point A to point B. As I said, if you want it to run on your laptop and compile on your server, this does require that your laptop be running a combination of OS and whatever that you can actually cross-compile for. Most desktop OSs can't be cross-compiled for easily. You know, macOS is famously difficult to cross-compile for. And Windows is not all that trivial to cross-compile for either. If you want to cross-compile for Linux, that's actually quite easy to do. Lots of things will do that for you. But yeah, just in the specific circumstance you work. But yes, you can cross-compile. You do have to have the cross-compilation tools.
At the moment, the recent Windows version, like the Windows 10, has the Linux core.
Yes.
And I can install Debian as a second operating system on a laptop.
Yes.
So
then you could cross-compile it, yes. And you would probably, the easy way to do it, though, would be, as you said, to build it in a Docker container on the Windows box using the Debian kernel, rather than trying to do the cross-compile directly. Docker.
Can I save time this way, or?
So the main thing you're saving time on is, you know, managing the different profiles, especially if you've got open source libraries, right? So if you want to use something like Boost, for example, then you know Boost has a recipe, and Boost will compile on pretty much any platform. You know, it comes out of Conant Center. It will compile on pretty much any platform. The community has worked really hard to make Boost work anywhere. Have pre-compiled binaries for pretty much everything. I think they told me they have 94 different configurations of Boost pre-compiled on the web. You know, so in that sense, it'll save you time if you're just developing at home. You know, you really don't want to have to screw around, you know, with compiling Boost. In terms of, you know, if you're really only compiling for one architecture, is it saving you time, you know, from a management perspective? One library at a time? No, as you start to have more libraries, you know, and you have to start managing them and worrying about how that all, you know, how they all fit together. Yes, absolutely, right? You know, if you only have, you know, if your application is hello.cpp with hello.h and all you have to do is compile that and it will run, then no, Conant is not saving you any time. If your application has, you know, a couple of open source libraries it's depending on, and sometimes you want to build it on your server, sometimes you want to build it natively on your desktop as opposed to on a second OS, something like Conant will make it a lot easier to manage those cross-build settings for you.
And what if I have not one server, but multiple servers with different architectures? Let's say I have a Windows server on Intel hardware and NVIDIA GPUs, and I have a few fully AMD builds, and I have an Apple laptop. How I should set up the system to deploy
so
such cluster?
I mean, that's a somewhat more in-depth question than but let's just say this is basically how we do it. When we're building these open source packages, you know, we have a Windows server, a Mac server, and various other things that we're compiling out on in order to get You know, in order to have 94 different configurations of Boost for every version of Boost, it's a fairly complex CI environment that goes out and builds it on half a dozen different servers with different configuration settings each time and different compilers each time. You know, and Conant makes orchestrating that easier. It doesn't do, you know, everything for you, right? Conant is not a build system, right? You have to get your CMake right as well. To do that. You know, there's a lot of pieces. If you want, at some point, I can, you know, show you some of the pieces that we have afterwards.
Yeah, I'm curious. Like, if you have a system with a bunch of dependencies, like, and most of them are owned by you, which means that you like change them fairly often. Then would it help, like, if you go have them in Conant? Because like what I had basically a huge Git repo with a bunch of like Git externals, and like, far from optimal solution, and it creates a lot of pain. But then, like, at least your like normal ID tools and code completion works. And here, I'm not sure.
No, it's a fair question. So from a source perspective, you often end up needing some of the same things. This is an area that we're really trying to optimize today, right? We're working with the community on. You know, from a pure build it perspective, the answer is it helps quite a lot.
Yeah, but it just speeds up the build.
Exactly. Now, we recently introduced a concept called Conant workspaces that's still in experimental phase. And today, it's just about, you know, managing the binaries for it, but we are looking at, like, how do I get the sources into that? We don't have a good answer for you right now, but it's actually something that I'm hoping. I just got done telling my boss that we had a lot to do this summer and very little time to do it in. So I know full well that I can't commit to any timeline on when we'll have that capability in the system.
Yeah, because it would be nice to have, like, you know, only the dependencies that you actually care about, and the rest just handled for you. But
Absolutely. No, and this is exactly what Conant Workspaces is starting to do. And I'd encourage you, if you're interested in that and interested in Conant, go out and take a look at what Conant Workspaces is doing. File GitHub issues on this is the behavior I want. You know, as a product manager of an open source project, the cool thing is that my community talks to me. The sad thing is that sometimes people think that the only time I want to hear from them is when they have a pull request or a bug. It's not true, by the way. Like really, if you try out a feature, especially if it's marked experimental, and you want to see something, talk about it, discuss it with people. Have a discussion on GitHub discussing how you think this should be working versus how it is working. And yes, if you also want to submit a pull request, that will be very welcome. But the feedback alone is also welcome, you know, so that the maintainers can figure out what to do. You know, we spend a lot of time trying to figure out the answers to questions like this. And any ideas we can get from the community help, you know, in terms of what do you really want. I can tell you, as a product manager who also works on non-open source, pretty much that's all I care about as a product manager. What do my users actually want? The cool thing about an open source community is that, in theory, it should be easier for them to tell me that. In practice, sometimes. But, so yeah, we're working on it. There's some cool stuff. I do recommend you try out Conant Workspaces and see, but I know that it doesn't really address the concern you have yet, but we hope that it will someday. Any other questions?
Yeah.
Yes?
Firstly, thank you for the product. Conant make me happy. And sometimes I want to write extra Python scripts for Conant.
Mm-hmm.
Does they exist? Don't copy from one repo to repo and maybe keep in the Conant this script.
Yeah. So we've done a little bit to make this easier recently, where if you create the Python package as a Conant package, it kind of works, but we know that it's really not enough on the Python requires side. We had a meeting with the part of the community that could come to JFrog's user conference just a month ago, and this was brought up there as well. Internally, we call it Python requires. But the solution that we already kind of have and that we're pushing, to try to make broader is the idea that you make that Python into a small Conant package that then your Conant package depends on, possibly as a build requires or something. But there are some precedence issues depending on the circumstances. I have to admit that I am the product manager, not in R&D. And so the specific details of which circumstances it'll work and which ones you'll run into problems with escape my mind right now. And probably I didn't have a good firm grasp of it when they explained it to me. I'm afraid I do a lot more paperwork than I write code these days. Yes, that is sadly a true statement. So in some circumstances we have something that works. In some circumstances we don't. We're looking for solutions. And what do people want that workflow to look like? And I believe there's open GitHub issues on this already. And if you can look at those GitHub issues and comment on them, that might help illuminate our thinking of what to do next. Did that answer your question? By the way, for questions like this also, we have a Slack channel on CPP Lang Slack. If you go to the top of our website, it's conveniently shown right at the top of our website. There's a Slack icon. Go out to our Slack Conant channel on CPP Lang. A lot of the open source community is there and able to answer questions. And generally speaking, if they don't answer the question, somebody from the Conant development team will get to it in relatively short order. So if there's a technical question that I can't answer tonight, I do apologize for that. As I said, I'm the product manager, not one of the development leads for Conant. But you can go out and join our Slack channel, and I assure you that somebody will be able to answer your question there. Other questions? OK. Well, hopefully some of you guys will try this out. And as I said, I'm out on the Slack channel. I'm on Twitter. Whatever you want, I want to hear your feedback. I hate it. I love it. It's useless. It's the best thing since sliced bread. It makes me happy. It was really nice feedback. Thank you. So always feel free to reach out. I try to be pretty responsive as I can. And thank you very much for hosting me, JetBrains.